This is part 2 in a series of videos on bolting for caving, and I'm going to cover bolt placement in this video. I'm going to focus on placing wedge bolts, and I may have a later video that covers other types of bolts like glue ends and self-drives. If you haven't seen part 1 of the series, which talks about different types of bolts, you may want to watch that first. I'll put a link to that video in the notes below.
So if you're going to drill holes in rock, you need to use something like this. This is a rotary hammer. A little bit different than a hammer drill. Hammer drills use clutch plates or cam plates to oscillate the bit as it turns. Rotary hammers actually have a separate pneumatic action that drives the bit back and forth at a very high frequency and high amplitude. And it really helps to chisel or break apart the rock as it drills the hole. And so, unlike when you're drilling into wood or metal, you're not actually cutting a hole, you're sort of chiseling out the hole. And so the really important mechanism is the back and forth oscillation of the hammer function. The threads on the drill bit don't actually have sharp edges, they're dull, and all they do is carry the rock that is chipped away from the end of the bit out of the hole. The bits that are used are SDS or SDS plus bits. They have these grooves in the end designed to be used with rotary hammers, and on the other end it's got a carbide tip. This is a relatively lightweight rotary hammer made by Rockwell. It's only about 3 pounds, but you can tell if you're getting the right type of rotary hammer if it has a fitting for an SDS bit. So it takes a special, it's not a standard chuck, it's an SDS chuck, and if it'll take this SDS type of bit and it has that hammer action that's separate from the drilling action, that's what you're looking for. If you need to drill really large holes, very deep holes, something like this might be more appropriate. This is a gas-powered rotary hammer from Ryobi. They don't make these anymore, but there's some other brands out there. But this has a fair amount of power and allows you to drill larger diameter holes. May not be suitable for bolt climbing, but for enlarging cave passage and stuff like that, it's hard to beat this. So before you start drilling holes, you want to find a good placement. And you want to avoid any weaknesses in the rock, any cracks. You want to stay away from edges. Bolts are going to be stronger if they're towards the more massive part of the rock. Depending on the placement, you might want to put it in a bulge, or you might want to put it in a little bit of a concavity. Concave areas like this are inherently a little stronger, but because it's set back, maybe once you clip a rope in, it might contact the surface of the rock, and that's not desirable. And so you want an area where the hanger, the bolt hanger, can lie flat against the surface, and it's good quality rock. The best way to tell the quality of the rock is to use a hammer, and you tap around, and you're looking for hollow sounds are typically a bad sign. Higher pitched ringing noises are typically a better sign. And if there's any surface weakness, there sometimes is, and especially in caves you may have mud or surface crust or things like that. Sometimes you have a little bit of a weak layer on the outside of the limestone. You want to clean that off with the hammer so you have a nice clean limestone surface to work with. To drill the hole, you want to know how deep. Generally it's a good idea to put the bolt on the hanger with the nut on it. This is your embedded depth. That's what's going to be in the inside the rock, and you can measure up against the drill bit like that. So we need to drill at least halfway down the threaded length of the drill bit in order for that to be able to sink all the way. When you go to drill the hole, you want to drill perpendicular to the surface of the rock. You don't want to be at an angle, either up or down. You really want it to go straight in. These bolts are designed so that they're very strong both in shear and in tensile. In other words, if you pull perpendicular to rock, they're strong, but they're also quite strong pulling out from the rock. So the important thing is that you get the bolt as deep into the rock as possible, and that the hanger sits flush to the surface of the rock. So the hole needs to be perpendicular to the rock for that to happen. When you go to drill, you want to put very light pressure on the drill. You don't want to push into it with all your body weight. You want to let the drill bit do most of the work. If you push too hard and try to drill the hole faster, it tends to overheat the tip of the drill bit, and it'll wear out that tip, and it won't function as well. So let the drill bit do the work. You really only need to put about 10 pounds of pressure against the drill to get it to drill the hole. Once the hole's been drilled, we want to clean the hole. So you can see there's quite a bit of rock flour, and a lot of that's already come out of the hole, but there's some that's residual in the hole. And if we go ahead and place a bolt, especially a sleeve bolt, but even with a wedge bolt, rock flour that lines that hole will kind of act as a release agent, and it will weaken the bolt, and we don't want that. So we want to get most of the rock flour out of it so that the wedge can adhere to the surface of the hole, bond straight to the rock. There's a couple devices here for cleaning the hole. This is a simple plastic tube known as a blow tube. I generally start with that, and then I have a nylon brush that I can go in and clean some more rock flour out. And I do 2 or 3 cycles of blow tube and nylon brush to get the hole clean. Some people use compressed air. Some people use a little bulb. The advantage of that is you're not using your breath, so that you don't have as much humidity or moisture, which if you blow too much into a hole, it can the moisture from your breath can cause the rock flour to cake up. Next, we take the bolt, nut, and hanger assembled and place it and hammer it into the hole. You want to make sure the hanger's on here, because if you hammer it in without that, you might overdrive the bolt. You won't be able to pull it out after it's hammered in. It's a pretty tight friction fit, and so we set it in there. You may want to have the hanger oriented in the direction of pull. Also, you want the nut to be screwed down a couple of threads, so that when you hammer on the end, you're hammering on the stud of the bolt, not on the... You don't want to hit the nut itself, because that may damage the threads. So the idea is you want to hit... and it'll go in there pretty tight. You can make some last minute adjustments, possibly with the angle of the hanger, before you tighten it up, but once it's set flush, you're ready to tighten the nut. The next step is to tighten the nut. What that does is it pulls the cone in the bottom of the bolt into the wedge and expands it, and locks the bolt in place, and that's what gives it its strength. You use a standard wrench. It'll take 4 or 5 turns to get it to tighten up, and the more you turn it, the tighter it'll get. Every bolt has manufacturer rated torque that you're supposed to tighten these to, and if you're less experienced, you may want to use something like this, a torque wrench, and you can put this on here. You can set these to a particular value, and in this case it's a Powers bolt. These are rated for 25 foot-pounds, but every bolt and every bolt manufacturer has a slightly different specification. The idea is you don't want to over-tighten them. You don't really want to under-tighten them either, so you want to be in a particular range. As you get more experience with placing bolts, you can get a feel for how tight to set them. 25 foot-pounds means if you have a 1-foot lever and you pull on it with 25 pounds of force. So with a shorter wrench, you have to get to 40 or 50 pounds of force, and that's going to be the proper torque. So there it is, a fully set bolt.
Thanks for watching. If you enjoyed this video, then please click the like button. Subscribe if you aren't already, so you can learn about other videos on the subject of caving, and comment below to let me know how I'm doing or to suggest other caving related topics.